One of the great things about quadratic equations is that we can use them to solve equations that aren't quadratics, provided they sort of look like quadratics. And it's a little confusing. So when we look at example 4 on page 290, we have x to the fourth minus 5x squared minus 36 equals 0. Now, it's not a quadratic because we have x to the fourth. But it does kind of look like a quadratic. You know, our quadratics have 3 items in them, where the second item, the second x, is usually half the power of the leading one, our x squared. You know, we have x squared, then we usually have an x. We have x to the fourth, and then we have x squared. This is a perfect candidate to do a substitution and use the quadratic methods to solve, because it has the form of a quadratic. So to do that, though, we need to get rid of this x to the 4 and x to the 2, because that's really going to confuse us. So what we're going to do is we're going to use a u substitution. We're going to say that u equals x squared, because that way we know that when we square u, as in u squared, it's equivalent to x to the fourth. So now we can rewrite this problem as u squared minus 5u minus 36 equals 0. And so it is a quadratic now, using the value of u. So we should ask ourselves, can we factor this? Is there any factors of 36 that would make 5 when put together? Well, the factors of 36 I think of are 1 and 36, which are no way in shape going to give us 5. 2 and 18, which again are not going to give us 5 in any way, shape, or form. 3 and 12, it's getting closer. You know, 3 and 12, when you subtract them, give you 9, so that's not it. But let's see, 4 and 9. Ooh, 4 and 9 totally are going to be it, because 4 times 9 is 36, and 4 minus 9, or 9 minus 4, is 5. So I think that's the way we're going to go here. We're going to call this u minus 9 times u plus 4 equals 0. I know one has to be a plus and one has to be a minus because there's a minus right here. And I know the 9 has to be minus because of the 5 being a negative, and 9 is bigger than 4. So that should do it. Okay, if you're not sure, you can do the OI check, remember, where we check the outside and inside of the foil, and to see if it's actually minus 5u, and I think you'll find that it does. All right, so now we're going to go ahead and set them each equal to 0 so we can solve for u. So u minus 9 is equal to 0, and u plus 4 equals 0. If you're doing this in public, you want to be careful, especially when using the word u, because sometimes people will look at you funny because you're saying u minus 9, and they might say, what? I'm not minusing 9. So be careful when you're doing this in public and reading it to yourself out loud. All right, we move the 9 over here, so it looks like that u equals 9. And we move the 4 over, and so it looks like u equals negative 4. That's great. If we were solving for u, we'd be done. Anybody's from California, you may have seen those billboards that said, and you're on the highway, that say, if you lived here, you'd be home by now. Well, if we were solving for u, we'd be done. But what were we solving this problem for? It's right over here at the beginning, x. So we're not done. But we do know what u equals. Even though u equals 9, we also know that u equals x squared. And so here we can really say, you know, x squared is equal to 9, as in this 9 right over here. And we can say that x squared is equal to negative 4, as in this negative 4 right here. And then we can solve. To solve for x squared, right, we're going to take the square root of both sides. And because we started with a square, that means that x is going to be equal to plus or minus. In our case, the square root of 9 is 3. So there is one answer. It's really 2 answers, but there's one answer. We do the same thing here. We take the square root of both sides. And x is equal to plus or minus. And now here's where some fun comes in, because we have a negative sign that's inside of the radical. And that means that our old friend I is going to be a part of the answer. And once that negative has been taken care of by I, then it's just a matter of the square root of 4, which we know to be 2. And so this is plus or minus 2i. So this has 4 answers to it. We came back to the original, and I said, how many answers does it going to have? You would say it has 4, because the highest power is 4. And so we have 4. We have plus or minus 3. There's 2 answers. And we have plus or minus 2i. There's 2 more answers. The answers aren't always real. Sometimes they're real and imaginary in nature. But that means we get to use quadratic methods now. So the key being, if the term, first of all, if it has 3 terms, like a quadratic, and you look at the power of the middle term, and it is half the power of the outside term, whatever that may be, you can use quadratic methods to solve for this. Whether that means this is positive or negative or fractional, it doesn't matter. This process will work for all of it.